Hi everyone, in this video we are going to introduce a new type of bonding. So up until this point, all of our bonding has been under the category either ionic or covalent. But now what we're going to do is introduce hydrogen bonding. So hydrogen bonding is really the true reason why water is such a freak, okay? So what we're going to do in this video is introduce the concept of hydrogen bonding, and then in future videos we're going to go through the different effects of it. But before I go any further, I want to map out the different types of bonding in chemistry, or at least the 3 different ones we talk about in this course. So we're going to start off by having bonding as our global topic, so that's going to be the top part. We're going to break it into 2 sections. So we can either have what's called intermolecular bonding, or you can have intramolecular bonding. So if you have intramolecular bondings, that is going to be the bonds within the molecule, okay? So these are your classic bonds. This is your ionic and covalent. Inter is our new species. This is the new thing we're going to be talking about, and this is actually the type of bonding that occurs between molecules. And so I'm going to draw this out in just a second to give you a visual of what that actually means. But before we go into that, I just want to show the different categories here. So for intramolecular bonding, this is where we talk about either ionic or covalent bonding. So we know at this point that ionic bonding is our transfer of electrons. So we know one atom is fully donating its electrons to another atom. Whereas with a covalent bonding, we know that it's going to be sharing electrons. So let me draw something out here before we touch on hydrogen bonding. Hold on, stay with me. So here's our water molecule. Right here, that bond is considered a covalent bond. We are sharing the electrons between the oxygen atom and the hydrogen atom. Now, intermolecular bonds are when the bonding occurs between molecules. And so our only example we're going to discuss in this course is called hydrogen bonding. So hydrogen bonding has a very, very, very specific definition. So make sure you write this down. It is a bond between a hydrogen atom in molecule A, or in one molecule, okay, in molecule A, and a nitrogen, oxygen, or fluorine in molecule B. So you have to have 2 different molecules in order to have hydrogen bonding. And now the kicker is you absolutely have to have a nitrogen hydrogen, an oxygen hydrogen, or a fluorine hydrogen. All of these are covalent bonds within one molecule in order to have hydrogen bonding. Now that seems unbelievably confusing. Let me draw a picture and see if we can make sense of that. So the covalent bond we said is this bond right here. So it's the bond between the oxygen and the hydrogen. But if I draw out a second water molecule, so now we have 2 different molecules, I'm going to draw a bond between this hydrogen right here and this oxygen right there. So what we do is we draw the bond like this. They have these long dashes like that. So there's a lot of arrows. Let me clean this up here. So these long dashes like that, that bond right there, that is your hydrogen bond. Hydrogen bond. It's not an ionic bond. It's not a covalent bond. It's a hydrogen bond. Your covalent and ionic bonds are within your molecule. That's what directly coordinates, or what directly connects one atom to another atom. Your hydrogen bond connects one hydrogen of one molecule to an oxygen, nitrogen, or fluorine on another molecule. Okay, so those very, very different. And so now what you have to see is you have to make sure that it has this covalent bond, the oxygen hydrogen, the nitrogen hydrogen, or the fluorine hydrogen bond, in order for that hydrogen bond to even exist. Okay, so you absolutely have it. There's a lot of different criteria of this. We're going to do a couple different examples to hopefully kind of solidify this concept, because in the very beginning it is very challenging to actually identify the hydrogen bond. So let's start off by looking at N2. Will N2 exhibit hydrogen bonding? Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. Step 1, the first thing you do is you draw out your molecule. So N2 looks like this. All right, step 1 is draw it out. Step 2, is there a hydrogen atom in the molecule? No, there is no hydrogen atom in this molecule. There's no way possible for this to have any hydrogen bonding. So in N2, there's no hydrogen bonding. Now, next question, H2O. Is there hydrogen bonding here? Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. Let me show you how I would have personally approached this problem. So the first thing I would have done is drawn out my water molecule. So you draw out your molecule. That's number 1. Number 2, is there a hydrogen atom in the molecule? Yes, there is. Okay, so it could possibly be hydrogen bonding. Number 3, is there a covalent bond that is either an NH, OH, or FH bond? And yes, I see that right there. There is a covalent OH bond. Okay, that's question 3. Now, if I draw a secondary molecule, can I draw a hydrogen bond between either an oxygen, nitrogen, fluorine and a hydrogen atom in another molecule? Yes, absolutely. Right there, we definitely have a hydrogen bond. Is there hydrogen bonding in water? Absolutely. Definitely the answer is yes. All right, next question. What about H2SE? Go. All right, did you get an answer? Hopefully you did. The first thing you need to do is draw out this molecule. So it has the exact same structure as water, literally the exact same structure. So 2 lone pairs, and then it's connected to 2 different hydrogen atoms. First thing you do is you draw it out. Done. Second thing, is there a hydrogen atom at all? Yes. Is there a covalent bond, an NH, OH, or FH covalent bond within the molecule? No. There is no OH, NH, or FH. So which means there's no hydrogen bonding, okay, in this molecule. Can't be possible. Last question, NH3. Is there hydrogen bonding? Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. Step 1, draw out your molecule. So we've drawn out ammonia a bunch in this module, so hopefully we have this structure down. Then we say, is there a hydrogen atom? Yes, there's 3 different hydrogen atoms, so it could possibly have hydrogen bonding. Next thing, is there a covalent NH, OH, or FH bond? And yes, I see one right here. We have a covalent NH bond, so definitely could possibly have hydrogen bonding. So the next thing you do is you would draw out another structure and see, is it possible for you to actually draw out a hydrogen bond? And yes, absolutely. You can definitely draw out a hydrogen bond for ammonia. Does ammonia exhibit hydrogen bonding? Absolutely, it definitely does. All right, so now I'm going to do one more example. I'm not going to make you actually do this one, but I want to point this out because a lot of students get very confused with this concept. So let's look at a very, very simple ether. Very simple ether. So we're going to have an oxygen in the center, and then we have our methane groups at the end. So now let me just add my lone pairs to make it a perfect structure. All right, so now, first thing we do if we're looking to see if it has hydrogen bonding, we draw out the structure. Done. Second thing, does it have hydrogen atoms? Absolutely. So it definitely could exhibit hydrogen bonding. Is there a covalent OH, NH, or FH bond within the molecule? No, there is not one. Yes, there is an oxygen. Yes, there is a hydrogen, but they are not directly coordinated. If they are not directly bonded, then you cannot exhibit hydrogen bonding. So can this structure exhibit it? Absolutely not. No hydrogen bonding in that structure, in that molecule, okay? So hopefully that makes sense. The last thing that I want to do now that hopefully we can fully understand when something has a hydrogen bond or not is I want to compare the relative strength. So for this course, we're going to memorize 2 very global trends. In terms of strength, we're going to say that ionic and covalent bonds are relatively the same strength. There are arguments for and against this. It totally depends on which structure you're talking about and which chemist you're talking to. So for our course, ionic and covalent, relatively the same strength. Now here's the big important thing. Regardless of ionic or covalent, they're significantly stronger than a hydrogen bond. Okay, I'm going to say that again. And ionic and covalent bonds are significantly stronger than hydrogen bonds. That is because these bonds are within the molecule. Okay, there's 2 atoms fighting over those electrons. They're actually sharing those electrons. That bond is going to be so much stronger, so much more difficult to break than something that's just between molecules, okay? So this right here, ionic covalent, that's like having your shoulder and your elbow connected, okay? It's your arm. It's going to be incredibly difficult to break somebody's arm. However, a hydrogen bond is holding hands with somebody else. If you're holding hands with somebody else, it's really easy to drop that bond and to let go of their hand, but it doesn't shatter your arm. So when you think of this, within molecule is going to be much stronger than between molecules, okay? Last question. If I draw this out, I'm going to draw water here. I'm going to draw another water over here. I'm going to draw this. We're going to label this A, and we're going to label this B. Which is stronger, A or B? Go. Did you get an answer? Hopefully, really quickly, you were able to identify that B is definitely stronger. B is a covalent bond, A is a hydrogen bond. Covalent bond always trumps, in terms of strength, always trumps a hydrogen bond. That's it for today. Take care of yourself. Drink water.